Hi! Welcome to this video on matrix multiplication. In the right top corner we see the assignment. We need to add all these matrices together, so we need to do a lot of calculations. This assignment appears on a test without a calculator, so this means we would have to grind m all the way up to m to the sixth to make this sum work. That takes a lot of time. It's also really boring. So maybe when you do this by hand, you just calculate, multiply until you reach m to the sixth. You may not have enough time for other exercises, which is not good. But the fact that this appears on a test without a calculator means that there's something else that we can find. That's a sign. The fact that it appears on a test with a calculator, something that takes long, that is boring, means that there's something else that we need to find. So we're going to start, and the only place where we can start is m squared. We already have m. The first term is m cubed, so we need m squared to get to m cubed. Now there's no trick about that. We just have to do it. Doesn't take that long. Just multiply m by itself, -1. So we get 2 times 2 plus 1 times -3. We get 2 times 1 plus 1 times -1. We get -3 times 2 plus -1 times -3, and we get -3 times 1 plus -1 times -1. So the answer to m squared is 2 times 2 is 4. 4 plus 1 times -3. 4 minus 3 is 2. 1, I mean. 4 minus 3 is 1. Below we have -3 times 2 is -6, plus -1 times -3 is 3. -6 plus 3 is -3. Right top corner, 2 times 1 is 1, plus 1 times -1 is -1. So 2 times 2 plus -1 is 1. -3 times 1 is -3, plus -1 times -1 is 1. -3 plus 1 is -2. So this is the answer for m squared. And now if we didn't see what I'm about to tell you, you would have to multiply this again by m to get m cubed, and so on until you get to m to the sixth. But now when we look at this result, m squared, it stands out that this diagonal here remains the same in the original matrix. And the other thing that stands out is that this entry 2 here in the original became 1 here, and this -1 became -2. So this means we would also get this result if we would take the original matrix and subtract the identity matrix. 2 minus 1 is 1. 1 minus 0 is 1. -3 minus 0 is -3. And -1 minus 1 is -2. So we would get the same result by subtracting the identity matrix from m. So instead of continuing with our multiplication, which would take forever, we are going to write m squared equals m minus I, where I is the identity matrix. And this is the thing that we need to see to make this exercise more simple. Because now, when I need m cubed, I could just write that is m squared times m, but m squared is m minus I times m, which is m squared minus im. We just distribute this m. M squared, we already had an expression for m squared, which is m minus I. It's a pretty ugly m, like this. So that is m squared, and then we have minus im. But im is just the product of the original matrix times the identity, and every time you multiply a matrix by its identity, you just end up with the same matrix. So we might as well not write that I and just write m, because im simplifies to m. This leaves us with an m minus I minus m. These m's cancel out. M minus m is 0. And negative I is what is left. So m cubed is equal to negative I. And that is pretty remarkable. That's pretty simple as well. So here in our assignment at the top, we are going to write that m cubed is actually negative I. So now for m to the fourth, I can say m cubed times m, but m cubed is negative I. Negative I times m is just m, just like we saw before. So basically m to the fourth is negative m. Negative m. And then for m to the sixth, we can do two things. We can multiply m to the fourth and m squared, or we can multiply m cubed by m cubed. If you choose to do m to the fourth times m squared, it would become negative m times m min I, which is longer than just this negative I of m cubed. So it would still be doable, but it's longer than m cubed times m cubed. So I'm just going to do m cubed times m cubed. Which is negative I times negative I, which is just I. So m to the sixth is I. And then we have everything we need to do this sum. Pretty easy, because we see that all these things cancel. This I cancels with this negative I, this m cancels with this m. And so our answer is the zero matrix 0, 0, 0, 0. Not just the number 0, because m is a 2 by 2. And when you multiply a 2 by 2 times itself, the answer will always be a 2 by 2. So we need to say 0, 0, 0, 0 as our answer. So this was my video. I hope you learned something, and thank you very much.